picture this. It's the middle of July. The downstairs of your house feels barely tolerable, but the upstairs bedroom feels like a different climate. The air conditioner is running. The vents are blowing. The thermostat says the house should be comfortable. But somehow, one room still feels sticky, heavy, and hot. So you lower the thermostat. Again, the unit runs longer. The electric bill climbs higher. And by the end of the month, you're staring at a number that makes you wonder how cooling a house became this expensive. But here's the strange part. Before central air became normal, before 4 outdoor condensers units sat beside every house, before people started treating summer comfort as something only a machine could provide, older homes had a different understanding of heat. They did not think of cooling as one appliance. They thought of the entire house as a cooling system. The attic mattered, the shade mattered, the basement mattered, the porch mattered, the direction of the wind mattered. And most importantly, the ground beneath the house mattered. Because even when the air above your roof is hot enough to shimmer, the earth below your feet changes temperature much more slowly. That is why an old basement can feel cool in summer. That is why a root cellar could keep food from spoiling before refrigerators. That is why spring houses worked. And that is why some old farms, homesteads, and experimental houses used underground air paths, cellars, and earth contact to take the edge off summer heat. But let's be clear from the start. This is not magic. This is not a secret system that will keep every home at 55 degrees forever, and it is not something every homeowner should start digging tomorrow. In the wrong soil, the wrong climate, or the wrong installation, underground cooling can create serious problems. Mold, condensation, radon, drainage trouble, pest entry, code issues, even trench safety risks. So this video is not about chasing a miracle hack. It is about understanding something old homes understand better than many modern houses do. The ground can be part of a home's cooling strategy, but only if you respect the limits. And once you understand those limits, you'll start seeing your house differently. Not as a sealed box fighting the sun with one overworked machine, but as a system that either works with heat or fights it the expensive way. Let's start with the simplest thing old homeowners knew. Go down into a basement on a hot day, and it usually feels cooler. Not because the basement has a hidden air conditioner. Not because the concrete is doing something mysterious. It feels cooler because the earth around that basement is acting like a massive thermal buffer. Outdoor air changes fast. A roof can get hot fast, an attic can turn into an oven fast. But soil does not heat and cool the way air does. The ground has mass, a lot of mass, and mass resists quick temperature swings. When the sun heats the surface of the earth, that heat does not instantly travel deep underground. It moves slowly. By the time summer heat begins pushing deeper into the soil, the season may already be changing. That is why underground spaces tend to lag behind outdoor weather. In summer, they feel cooler. In winter, they often feel warmer than the air outside. Old builders did not need modern sensors to notice this. They felt it. They walked into the cellars. They stored apples, potatoes, jars, milk, and vegetables underground. They built spring houses over cold flowing water. They used shade, stone, earth, and airflow because those were the tools they had. And those tools worked well enough that families trusted them for generations. A root cellar is one of the clearest examples. A proper root cellar is not just a hole in the ground. It is a controlled storage space using earth temperature, moisture, darkness, and ventilation. The earth slows temperature change. The darkness protects food. The moisture keeps certain produce from drying out. And the vents allow stale air to leave while fresh air enters. That is not folklore. That is practical physics. The same idea appears in spring houses. A spring house was often built over a natural spring or very cold groundwater. The cold water helped keep the building cooler inside. Milk, butter, and other perishables could be stored there before modern refrigeration. Again, not magic. Just a smart use of a natural temperature source. Now apply that thinking to the home itself. Old homes often had features that helped manage heat before anyone touched a thermostat. Tall ceilings allowed warm air to rise. Deep porches shaded windows and walls. Trees reduced direct solar heat. Operable windows were placed for cross ventilation. Attics were ventilated so trapped heat could escape. Basements and crawl spaces were sometimes part of the home's temperature behavior. In other words, cooling was not one device. It was a chain of decisions. Modern houses often broke that chain. Many newer homes depend almost entirely on mechanical cooling. The house gets sealed tighter. The attic gets hotter. The roof absorbs heat. Ductwork may run through brutal attic temperatures. Windows face the sun without enough shade. And then one air conditioner is expected to solve every mistake. That is where the bill comes from. You are not just paying to cool the air. You are paying to fight the design. This is the point most people miss. A powerful AC unit can hide a weak house system, but it cannot make that weakness disappear. If your attic is cooking, if your upstairs rooms are absorbing heat all afternoon, if your ducts are leaking or sitting in extreme temperatures, if your windows are letting in sun like glass radiators, your cooling system is not starting from zero. It is starting from a disadvantage. Old homes, at their best, tried to reduce the heat load before mechanical cooling was needed. And one of the oldest ways to do that was to use the ground as a cooling influence. This brings us to underground air systems, sometimes called earth tubes or ground-coupled ventilation. The basic idea is simple. Air travels through a buried pipe or underground passage before entering a building. As that air moves through the pipe, it exchanges heat with the surrounding earth. On a hot day, the ground may be much cooler than the outside air, so the air entering the house can be cooled before it reaches the living space. In theory, it sounds beautifully simple. Hot air goes in, cooler air comes out. But this is where honesty matters. The idea is real, the physics is real, but the results depend heavily on design. Pipe length matters, pipe diameter matters, depth matters, soil temperatures matters, soil moisture matters, drainage matters, airspeed matters, humidity matters, and maintenance matters. A short pipe buried too shallow in the wrong climate will not perform like a serious system. A pipe that holds condensation can become a mold problem. A pipe in radon-prone soil can pull unwanted gases toward the home. A pipe without proper screens can invite insects or rodents. A pipe installed without slope can collect water. And a pipe connected carelessly to a home can create more problems than it solves. That is why Silas will never tell you, just dig a trench and your cooling bill disappears. That kind of advice gets views. But it also gets people in trouble. The better question is not, can the ground cool a house? The better question is, how did older homes use earth, shade, air, and storage spaces to reduce heat safely? And what parts can a modern homeowner learn from? That question is much more useful because even if you never install an earth tube, understanding this principle can still help you make better decisions about your home. For example, think about your attic. Many homeowners treat the attic as dead storage space. Old trunks, holiday decorations, boxes nobody opens. But in summer, the attic can become one of the most important heat zones in the house. A hot attic can radiate heat downward. It can make upstairs rooms uncomfortable. It can force air conditioning to run longer. And if ductwork is in that attic, the problem gets worse. You may be paying to cool air that travels through one of the hottest parts of the structure. Old builders often took attic ventilation seriously because they understood hot air had to escape. Gable vents, ridge vents, soffit airflow, cupolas, whole house fans, high windows. These were not decorative ideas only. They were part of the home's heat strategy. A well-ventilated attic does not magically cool a house by itself, but a trapped, overheated attic can absolutely make a house harder to cool. That is the kind of practical lesson modern homeowners should care about first. Before chasing underground pipes, ask whether your attic is fighting your AC. Before digging near the foundation, ask whether your upstairs rooms are absorbing direct sun all afternoon. Before believing any miracle cooling claim, ask whether your home has basic heat control problems that old houses solved with shade and airflow. Now, let's talk about basements and crawl spaces. A basement is not just extra square footage. It is one of the clearest places where the house touches the earth. In many climates, a basement stays cooler than the rest of the house during summer because the surrounding ground buffers temperature. That does not mean you should simply open basement air into the whole home without thinking. Basements can have moisture, basements can have musty air, basements can have radon depending on location. Basements can have mold if humidity is not controlled. So again, the principle is useful, but the details matter. An old basement that stays cool and dry is a gift. An old basement that stays damp and musty is a warning. The same earth that helps moderate temperature can also hold moisture against the structure. That is why old home cooling and old home moisture control are connected. You cannot separate them. A cool space that grows mold is not a healthy cooling system. This is where many online cooling hacks fall apart. They talk about temperature, they ignore moisture. But comfort is not just temperature. A 74-degree room with high humidity can feel miserable. A 78-degree room with lower humidity and good air movement can feel comfortable. That is one reason modern air conditioning became so important. It does not only lower the temperature, it also removes moisture from the air. In humid climates, that matters enormously. So if someone tells you an underground pipe can replace air conditioning everywhere, they are leaving out the hardest part, humidity. In dry climates, earth-coupled cooling may be more forgiving. In humid climates, air traveling through a cool buried pipe can drop moisture inside that pipe. That condensation needs somewhere to go. If it does not drain properly, the pipe can become a wet, dark, dirty place. And wet, dark, dirty places are exactly where homeowners do not want their breathing air coming from. This is why some modern designs avoid sending household air directly through buried pipes. Instead, they use a closed loop. A closed loop does not pull outside air through an underground tunnel. It circulates water or another fluid through buried piping, then transfers that temperature through a heat exchanger. That approach can reduce some air quality concerns because the indoor air is not traveling through a buried air pipe. But even closed-loop systems are not casual weekend projects. They still require design, they may require permits, they require proper materials, they require leak protection, they require sizing, they require local knowledge, and they should not be sold as a cheap trick that works everywhere. The real lesson is not that every homeowner needs an underground system. The real lesson is that the ground is a temperature resource. Old homes respected that. Modern homes often forget it. And when modern homes forget basic heat behavior, they become more dependent on machines. Let's bring this back to a normal homeowner. Say you live in an older house. Your summer bill is high. The upstairs rooms are uncomfortable. You've heard about root cellars, basements, earth tubes, and old farmhouse tricks. What should you actually do? Not fantasy, not fake secrets, real steps. First, study where heat is entering your home. Most people start with the AC unit because it is the loudest machine. But the better starting point is the heat path. Is the attic overheating? Are the upstairs ceilings warm in the evening? Are west-facing windows getting blasted by afternoon sun? Are curtains or exterior shades helping at all? Are doors leaking hot air? Are ducts in hot spaces? Is the crawl space damp? Is the basement cool but musty? Is the home getting enough controlled ventilation? This kind of observation costs nothing, and it tells you more than lowering the thermostat. Second, look at shade. Old homes used shade as serious infrastructure. A porch was not just a place to sit. It shaded walls and windows. Trees were not just landscaping. They reduced solar gain. Awnings were not just decoration. They blocked the sun before it hit the glass. Modern homeowners often spend thousands cooling heat that could have been blocked before it entered. Exterior shade is usually stronger than interior shade because it stops sunlight before it becomes heat inside the room. That does not mean every home needs a porch or a giant tree, but it does mean west and south-facing glass deserve attention. Third, look at attic behavior. If your attic is trapping heat, the whole house pays for it. This does not mean randomly adding vents without understanding the system. Attic ventilation has to work with the roof design, insulation, moisture control, and local climate. But the basic question is simple. Is hot air being trapped where it should be leaving? A good home inspector, energy auditor, roofer, or building professional can help identify whether attic airflow is working or broken. Fourth, understand insulation correctly. Insulation does not create colds. It slows heat movement. That means insulation can help keep heat out in summer and heat in during winter. But insulation installed badly can also trap moisture, block ventilation, or hide problems. Old homes often breathe differently than modern homes. So adding modern materials to an old structure without understanding moisture can cause damage. This is why just add more insulation is not always the full answer. The house is a system. Fifth, consider air movement. Before central air, people used fans, window placement, night flushing, and whole house ventilation strategies. In some climates, opening the house at night and closing it during the hot part of the day can help. In other climates, especially humid ones, bringing in outdoor air can make the house feel worse. So the method depends on the weather. Old wisdom was never one size fits all. It was local. That is something modern advice often forgets. A trick that works in dry Colorado may fail in coastal Florida. A basement strategy that works in Michigan may be useless in Louisiana. A root cellar that works in one soil may flood in another. This is why the safest phrase in home resilience is, it depends. Not because the idea is weak, because the house, climate, soil, and moisture all matter. Now let's return to underground cooling directly. Could a homeowner use some version of earth-coupled cooling today? Yes, in certain cases. But it should be treated as a building science project, not a viral hack. A safe evaluation starts with questions. What is your climate? Is the air humid or dry? What is your water table? Does your area have radon concerns? What type of soil do you have? Can the pipe drain? Can the system be cleaned? Can pests be blocked? Will it meet local code? Can it be safely installed without trench collapse? Does it supplement the existing system? Or is someone pretending it will replace everything? Those questions are not boring. Those questions are the difference between old wisdom and dangerous guessing. For many homes, the better path may not be a buried air tube at all. It may be improving attic ventilation, adding exterior shade, sealing duct leaks, moving or insulating ductwork, managing humidity, using a dehumidifier where appropriate, improving basement moisture control, installing a whole house fan in the right climate, or considering a professionally designed ground source heat pump if the budget and site make sense. That may sound less exciting than a secret tunnel under the yard, but it is more honest, and honest systems last longer than viral tricks. Here is where old homes still have something powerful to teach us. They were often built with an awareness of seasons: summer sun, winter wind, rain, shade, moisture, airflow, storage, thermal mass. The house was not separate from the land. It was placed on the land. It responded to the land. Modern homes often try to overpower the land. They seal the box, install the machine, and send the bill to the homeowner. That approach can work, but it can also be fragile. When power gets expensive, the weakness appears. When the grid fails, the weakness appears. When the AC unit breaks during a heat wave, the weakness appears. When one room never cools, no matter how long the system runs, the weakness appears. The old approach was different. Reduce the heat first, use the structure, use shade, use the ground where appropriate, move air intelligently, store food in cooler spaces, respect moisture, then use mechanical systems as support, not as the only line of defense. That is the Silas route way to look at it. Not anti-technology, not fake nostalgia, not pretending every old method was perfect. Just asking a better question, what did older homes understand that modern homes forgot? With ground cooling, the answer is this. The earth is not just dirt, it is thermal mass. It can slow temperature change, it can protect stored food, it can moderate spaces that touch it, it can help pre-cool air or fluid in carefully designed systems. But it can also bring moisture, gas, pests, and maintenance problems if handled carelessly. So the ground is not a miracle, it is a tool, and every tool has a right use and a wrong use. If you want the simplest practical takeaway from this entire video, it is this. Stop thinking of cooling as only a thermostat setting. Start thinking of cooling as heat management. Where is the heat entering? Where is heat being stored? Where is heat getting trapped? Where could shade stop it earlier? Where could airflow remove it? Where could the ground help? Where could moisture ruin the plan? That shift alone can save homeowners from bad decisions. It can also help you spot weak advice online. When someone says, this cools any home, be suspicious. When someone says no permits, no risks, no maintenance, be suspicious. When someone says the industry hid this, ask for proof. When someone says here are the limits, here are the risks, and here is where it works, listen more closely. Because real old wisdom does not need fake hype. A root cellar does not need a conspiracy to be useful. A spring house does not need a villain to be impressive. A shaded porch does not need a miracle claim to lower heat. A cool basement does not need to be called forbidden technology. These things worked because they matched the environment. That is the part worth recovering. Now imagine a better modern home. Not necessarily a new home, maybe your current home. The attic is no longer trapping brutal heat. The worst windows are shaded before the afternoon sun hits them. The basement is dry and monitored. The crawl space is not quietly feeding humidity into the house. The ducts are not leaking expensive conditioned air. The AC is not being asked to overcome every design flaw alone. And if earth-coupled cooling is considered, it is designed safely, locally, and honestly. That kind of home is not primitive. It is resilient. It uses modern systems, but it is not helpless without them. It respects the same principles old builders noticed long before central air became common. Heat rises, shade matters, moisture matters. Air needs a path. The earth changes slowly. And comfort is easier when the house is working with physics instead of fighting it. That is the forgotten lesson. Not that every yard needs a trench. Not that every house can be cooled for a few $100s. Not that some secret group banned common sense. The real lesson is sharper than that. Modern homeowners were trained to look at the machine first. Old homes force you to look at the whole system. And once you do that, you stop asking only, how do I make my AC run harder? You start asking, why is my house getting this hot in the first place? That is the question that saves money. That is the question that prevents bad repairs. That is the question that brings old home wisdom back into modern life. So before you believe the next miracle cooling claim, walk your own house. Stand in the upstairs room at 5 p.m., feel the ceiling, check which windows are taking the sun. Step into the attic safely or have someone qualified inspect it. Notice whether the basement is cool and dry or cool and damp. Think about shade. Think about airflow. Think about moisture. Think about the ground under your home, not as empty space, but as part of the temperature story. Because old homes did not stay cooler by accident. They stayed cooler when builders respected the land, the sun, the air, and the earth. And when modern houses ignore those things, the air conditioner gets the blame. But the real problem may be the house itself. Drop your state in the comments, your worst summer cooling bill, and whether your home has a basement, crawl space, or slab foundation. That will tell us more than almost anything else. Because cooling advice without climate and house type is just guessing. And on this channel, we are not here for guesses. We are here to recover the old system's modern life left behind and separate the useful wisdom from the dangerous shortcuts. Next, we are going to look at the part of the house most people ignore until it starts costing them money, the attic. Because in many old homes, the attic was not dead storage. It was a heat control zone. And if your attic is trapping summer heat right now, your AC may be fighting a battle it was never meant to fight alone.